My dear friends, today I'm going to discuss with you a very important topic. You know what's that? The topic is if we are having a magnet, okay, and if it is placed in a magnetic field, what will happen? Okay. The second point is what about the potential energy stored if the magnet is placed inside the magnetic field? Is there will be any potential energy or not? And if it is, then what is the reason of it? Okay, let's come with me in this video. One thing, please. If you like this video, please subscribe my channel. And one thing again, if you want to give the subjective test of 10 plus 1, 10 plus 2, you are most welcome. My WhatsApp number is 9888 169 226. Okay, let's come. So my dear friends, I'm going to discuss this article, talk on a bar magnet in a magnetic field. I think you are quite familiar with the case of electrostatic. In electrostatic, there was an electric field, okay, electric field like this, uniform electric field. The reason of, what's the reason of this electric field? The reason of the electric field is that some source of positive charge is here and some source of negative charge is here. So electrical lines are positive to negative. Okay, electric lines points positive to negative. Like that in our case, instead of positive we are having north pole and having a south pole, then magnetic lines, they will be north to south, mean uniform magnetic field. As here it was uniform electric field. And electrostatic, we placed a dipole minus q plus q, and minus q is equivalent to south pole of pole strength m, and plus q is equivalent to north pole, plus q is equivalent to north pole of pole strength m, right? Now here the dipole moment was minus q to plus q. The dipole moment p vector is q into 2l vector. Main direction is minus to plus, like this dipole moment, electric dipole moment. Likewise in magnetism, dipole moment is south to north. Like in electricity, electrostatic, minus q to plus q, here south to north. And similarly the magnetic moment will be the q, not q here it is pole strength m into 2l. Remember the direction of the dipole moment south to north. Now it is in a field. Now what will happen? This is external south pole. It will attract the north pole along this side. Okay, and this is external north pole. It will attract the south pole along this side. It will this north, it will attract south along this direction. This is external south. It will attract the north of this magnet along this direction. मीन ये मैग्नेट रखा है ना, तो मैग्नेट का ये साउथ नॉर्थ पोल है. तो आपको पता है कि जो मैग्नेटिक फील्ड बनी हुई है उसका कारण क्या है? उसका कारण है कि कोई ना कोई नॉर्थ पोल यहाँ होगा, तो साउथ अट्रैक्ट होगा नॉर्थ की तरफ. तो नॉर्थ पोल इस मैग्नेट का अट्रैक्ट होगा एक्सटर्नल साउथ की तरफ, तो दो फोर्सेस लगेंगी, एक इधर एक इधर. So there are the two forces, one along this side, one along this side. As in electrostatic, the force was this force was Q into E. Okay. Now similarly, here the magnetic force is not Q into E. In magnetism, it is M into B. So M into B is along this side, M into B is along this side. The two forces are equal in magnitude, opposite in direction. Remember, whenever the two forces come, and if there comes some perpendicular distance between the two, like this is perpendicular distance, one force, second force, then these two forces, they will constitute a torque. मतलब टॉर्क का बनता है जब perpendicular distance हो, दो forces हो, इक्वल ऑपोजिट फोर्सेस हों, तो ये टॉर्क का मतलब होता है कि वो क्वांटिटी जो इसे घुमाएगी ना, इसे जैसे टैब नहीं खोलते हम, टैब कैसे खोलते हैं, तो एक फोर्स इधर लगाते हैं, एक मतलब टैब में एक फोर्स इस तरफ लगाते हैं, एक फोर्स इस तरफ लगाते हैं, तो टैब ऐसे रोटेट करती है ना. तो वही है ना, यहाँ भी वही है कि ये परपेंडिकुलर डिस्टेंस है, एक फोर्स इधर लग रही है, एक फोर्स ये लग रही है, तो ये क्या होएगा, टॉर्क बनेगा. So, there are two forces, there are two forces equal and opposite, they will constitute a torque. तो torque में क्या होता है कि perpendicular distance का होना जरूरी होता है. So this is a perpendicular distance. So I am coming to this figure. Okay. So this is the perpendicular distance between this force MB and this force MB. This is a perpendicular distance. Right, this distance is perpendicular distance. Now if this length is 2L and this angle is theta, what will be the perpendicular length? Perpendicular over hypotenuse, sine theta. So perpendicular becomes 2L sine theta. So the perpendicular becomes 2L sine theta. So this is perpendicular distance. Now what is the definition of the torque? The either force into the perpendicular distance. So the torque is equals to either force MP into the perpendicular distance, 12 sine theta. So it becomes in magnitude. Torque is vector quantity. So here the expression in magnitude. So M 12B sine theta. Okay. Now you know very well what is a magnetic moment. There is the pole strength, small m into 2L. So this is the magnetic moment. So I replaced m into 2L by magnetic moment m. So it becomes mb sine theta. So where m into 2L is the magnetic moment. Okay, so this is mb sine theta because torque is a vector quantity. This is like ab sine theta, a vector cross b vector. This is ab sine theta into n cap. So ab sine theta is the magnitude of the cross product. N cap shows the direction. So similarly we are having mb sine theta. That means this torque, it is a vector quantity. So torque vector is m vector cross b vector. Okay, and what will be the direction of the torque, So think about the direction of the a vector cross b vector. The direction of this cross product is perpendicular to the plane in which a vector and b vector lies. Mean perpendicular to both in this plane. Similarly, torque vector will be perpendicular to this plane in which there is m vector and b vector. Now in magnitude it is mb sine theta. What is now the definition of m? M becomes torque over b sine theta. So if b is 1 unit and your magnet is at 90 degree to the field, Sine 90 becomes 1. B is 1 unit. Then magnetic moment becomes equals to torque. Now here you define the magnetic moment of the magnet. What is the significance of the magnetic moment? Magnetic moment will tell what is the strength of this magnet, whether the magnet is weak or strong. If this is weak, then the value of mu will be less. If the magnet is strong, okay, then the value of m will be high, large value, high value. Now second question for you, what will be the unit of magnetic moment? This you write yourself here, okay. Now next I am coming, because torque is mb sine theta. This torque will be, like this is magnet. If it is placed like this, because field is also along this side, if the magnet is like this, no torque will act, because here what happens here, theta equals to 0 degree. Theta 0 degree mean torque 0. But the question for you, if the torque is 0, what do you say? The forces are also equals to 0. No, forces are not 0. Forces are still acting, because this is, the north pole of the magnet, and here is the external south. So this force, south will attract it along this side. The force will be there, and this is, the south pole of the magnet, and this is external north pole. North pole will attract this south pole along this side. So there will be two forces like MB and MB, and there are two forces. One MB is along this side, other MB is along this side. Equal and opposite forces. Net force will become 0. Okay, and moreover there is no perpendicular distance, no torque, because theta equals to 0, not torque. But forces will be there in this position. In this position, torque is 0, but forces are still there. Don't say here force equals to forces are 0. Forces are there, but torque is 0. Now the torque starts acting. It is increasing. Forces are still the same. The torque is increasing, and if the magnet comes like this, the torque becomes maximum, because theta is 90 degree and sine 90 is 1. Maximum torque comes here in this position if the magnet is placed like this, because now the torque will rotate it like this. Okay, torque will tend to rotate the magnet like this. तो यदि देखो यहाँ पे है ना, तो फोर्सेस तो लग रही हैं, दोनों फोर्सेस लग रही हैं, पर उसका रिजल्ट कुछ नहीं है. रिजल्ट क्यों नहीं है? क्योंकि परपेंडिकुलर डिस्टेंस ही नहीं मिल रहा है, क्योंकि फोर्सेस लेंथ के ही अलॉन्ग है. तो लेंथ के अलॉन्ग है तो दो फोर्सेस में कैंसिल हो जाना है. पर यदि आप ऐसे करोगे ना, तो टॉर्क अब लगना शुरू हो गया, बढ़ता जा रहा है. यहाँ पे क्या हुआ कि टॉर्क मैक्सिमम हो गया, यहाँ बहुत ज़्यादा टॉर्क एक्ट कर रहा है. वो टॉर्क एकदम से इसको घुमाएगा ऐसे, है ना, उसका टेंडेंसी होगा टॉर्क का इसको घुमाना. पर जैसे जैसे घूमेगा ना, टॉर्क खुद ख़त्म होता जाएगा, कम होता जाएगा, और ऐसे आके ना टॉर्क तो ख़त्म हो जाएगा, जीरो हो जाएगा, टॉर्क जीरो हो जाएगा. मतलब यदि आप मैग्नेट को ऐसे रख देते हो, मैं एक क्वेश्चन बोलता हूँ आपको कि यहाँ पे एक्सटर्नल साउथ पोल है, यहाँ पे एक्सटर्नल नॉर्थ पोल है, राइट, और यहाँ पे एक्सटर्नल साउथ पोल है. तो क्या होगा कि टॉर्क लगेगा इस पे, है ना, ये मैग्नेट का नॉर्थ है, ये मैग्नेट का साउथ है, तो टॉर्क लगेगा, टॉर्क उसे घुमाएगा. जैसे जैसे टॉर्क घुमाएगा इसकी स्पीड बढ़ती जाएगी ना, ऐसे टर्न करने की स्पीड, क्योंकि इनर्शिया बनता जाता है. तो यहाँ पे आके टॉर्क तो ख़त्म हो जाता है, पर ये मैग्नेट खुद को रोक नहीं पाएगा. यहाँ पे रोक नहीं पाएगा तो ये ओवरशूट कर जाएगा ऐसे, क्योंकि जैसे आप दौड़ते जा रहे हो ना, आपको कहे कोई एकदम यहाँ रुक जाओ, तो यहाँ रुक नहीं पाओगे, आप थोड़ा और आगे ऐसे हो जाओगे, तो ये मैग्नेट थोड़ा और इस तरफ चला जाता है. अब इस तरफ जाता है, फिर टॉर्क लगेगा, टॉर्क उसे फिर घुमाने की कोशिश करेगा ऐसे, तो ये घूमेगा, यहाँ रुक नहीं पाएगा, फिर ओवरशूट कर जाएगा पोजीशन को। यहाँ आके फिर टॉर्क लगेगा, उसे वो पैरेलल करना चाहेगा, अलोंग करना चाहेगा, यहाँ टॉर्क 0 हो जाएगा, पर मैग्नेट रुक नहीं पाएगा, ओवरशूट कर जाएगा। दैट मीन द मैग्नेट विल स्टार्ट ऑसिलेटिंग इन द एक्सटर्नल मैग्नेटिक फील्ड लाइक दिस। वो ऐसे ऐसे ना ऑसिलेट करना शुरू कर देगा यदि आप मैग्नेट को फ्री कर देते हो तो। यदि आपने फ्री नहीं किया तो फिर नहीं होगा, ठीक है। तो इफ द मैग्नेट इज फ्री then tendency of the torque is to rotate, but the magnet cannot stop here, it overshoot its position, again the torque will act, again it overshoot this position, and this process continue and the magnet starts oscillating. Okay, and you can prove whether the oscillation is simple harmonic or not. That's the next question for you. Now I am coming the potential energy stored in a bar magnet. You know, coming this case, tendency of the torque is to rotate the magnet like this. But one thing you do, you go opposite to the tendency of the field. Tendency of the field is to rotate it like this. But you go against. Tendency of the field is to rotate it clockwise. But you go against means you go anti-clockwise. You move it anti-clockwise. So then you have to do the work against the tendency of the field. Okay, because you are going against. Whenever you go against, you have to do work. So if the dipole is rotated, torque is mb sine theta, and you rotate it d theta against the tendency. Okay, and in my case, you rotate it along anti-clockwise, along this side. Then this is a small work done, because rotating angle is very small. Substituting the value of the torque mb sine theta. This is the work done. Now if you are going to rotate theta 1 to theta 2, okay, theta 1 is initial angle, theta 2 is the final angle. Now sine theta d theta integration is minus cos theta. Limits, substituting minus sign is taken outside, substituting the limits. So minus is adjusted inside. So this is the expression. So if we think our first position is 90 degree, theta 1 is 90 and theta 2 is any other angle, then work done becomes cos 90 minus cos theta. Cos 90 is 0. So this is the work done. And this work done stored in the magnet when it is in a field as a potential energy. So potential energy is U, which is minus mb cos theta. And like AB cos theta is A vector dot B vector, and potential energy is a scalar quantity. So this is a dot product between M vector and B vector. Now there are certain things, certain points. Number one, if the magnet is like this at 90 degree, now torque is maximum, but potential energy is here 0 because theta is 90 and potential energy is equals to minus mb cos 90. Cos 90 is 0, so there is no potential energy here. Potential energy is 0, but torque is maximum. Again a question, whether this 0 potential energy is the minimum potential energy? The answer is no, this is not minimum. Why? Because when the magnet is like this, theta is equals to 0, torque equals to 0, but potential energy is equals to minus mb cos 0. Cos 0 is 1, it is minus mb. So here in this position, the potential energy is minimum minus mb. Minus sign mean it is a very stable state. And minimum potential energy. Minimum potential energy whenever it is, that means it is a stable, very stable state. But here when you rotate it like this at 90 degree, this state is not stable. whereas potential energy is zero. But zero potential energy is, greater than for this position, because here it was minus MB, here it is zero. Mean potential energy is increased. How much? From here to here, MB. It is increased by the value MB. So in minus MB, you add MB, then becomes zero. So never say zero mean minimum. Not zero mean not minimum here. If you further rotate it like this, anti-parallel dipole moment, magnetic moment of the magnet is anti-parallel to B. What happen here? The torque again becomes zero, because in the torque the expression is sine theta. Theta is 180, torque 0. But potential energy becomes maximum. Why? Because here it is cos theta. Theta is 180, cos 180 minus 1, minus plus, potential energy becomes MB. So when the magnet is like this, magnetic moment is in opposite to the direction of the magnetic field, then potential energy is maximum. Mean here it was 0, it is further increased by MB. So here potential energy is MB. Lastly, here potential energy is minus MB. Increased by MB becomes 0. Increased by MB becomes positive MB. So this is all about the potential energy. So in potential energy, this is a cos expression. In torque, it is a sine expression. So I think it is clear to you all the concepts regarding. Thank you very much. Please subscribe my channel. Okay? किसी ने क्या खूब कहा है, धूप में निकलो, घटाओं में नहा कर देखो, जिंदगी क्या है, सोच को थोड़ा सा बदल कर देखो. आजकल कोरोना हो रही है ना सब तरफ, पर किसी ने क्या खूब कहा, मैंने नहीं कहा, किसी ने कहा, धूप में निकलो, घटाओं में नहा कर देखो, जिंदगी क्या है, सोच को थोड़ा सा बदल कर देखो.